Good evening, calculus students. So, in this video should be relatively short because I am just going to go over this multiple choice page that is in your Quiz 3 prep packet because this page I think is the quote unquote toughest page, although I think as you see and as we do the problems, you'll see it's actually not bad at all because it applies the same things we already know. All right. Everything else is just graphs, mostly from Delta Math, that sort of stuff. So I think y'all should be able to sort of apply it intuitively and figure it out. Now, let's take a look. So the first derivative of the function f is given by f prime of x is equal to cosine squared x divided by x minus 1/5. How many critical values does f have on the open interval from 0 to 10? Well, let's think about this. The number of critical values. Well, what's a definition of a critical value? My definition should be that my derivative, f prime of x, is equal to 0, right? We've been knowing this, right? The first step, finding a critical point, I take my derivative and set it equal to 0. Now, this question is somewhat easier because what did they give me? Take a look at that. They give me my derivative, right? So I actually already know my derivative. My derivative is written here. It is cosine squared x, or actually I can rewrite that as cosine x. I'm gonna put that all in parentheses squared because it's the same thing, divided by x minus 1/5 is equal to 0, right? Cool. So I want to know how many times my derivative is equal to 0. Well, what I can do is, this is a calculator problem, so I'm going to pull up my calculator. Let me pull that up. All right. And I'm going to put in my equation that I just talked about. So cosine of x squared, cosine of x squared divided by x minus 1/5. Now, when I read this problem, I say I want to see how many times this equation is equal to 0 on the interval from 0 to 10, right? So I'm going to take a look at my graph, and let's zoom in a little bit and look at the part that's between 0 and 10. So 0 is right here, 10 is right here. In between 0 and 10, how many times does this graph equal 0? Right? This is like where we're getting proficient at reading graphs. Well, my y value of my derivative is equal to 0 here. So that's 1 time, 2 times, 3 times, and that is it. It does not touch 0 again. Once, twice, 3 times. That's it. So my answer here is how many times after looking at my calculator does this function equal 0? It happens 3 times. So my answer is 3. All right. Hopefully that makes sense. All right. Second problem, if g is a differentiable function such that g of x is less than 0 for all real numbers x, and if f prime of x is equal to x squared minus 4 times g of x, which of the following is true? Well, let's see. Which of the following is true? Relative maximums, relative minimums, minimum, maximum. Okay, so I need to find the relative max and mins. Right, so how do I find that? Step 1, we're going to find my critical points. Right, to find my relative maximums, my step 1 is to find my critical points, and to do that, I'm going to take my derivative, f prime of x. Right, this is another situation where they give me my derivative already, so I don't need to do any calculations. I take my derivative and I set it equal to 0. Right, cool. So let's just solve for x. Well, to do that, to solve for my critical points, x squared minus 4, I can factor this, so it's x plus 2. X minus 2 is equal to, times g of x is equal to 0. So what values of x are going to give me 0? Well, x could be -2. It could be +2. And how about g of x? Can this ever be 0? Could I input something for x that would make it 0? And the answer would be no, because g of x is always less than 0. Right? So my only critical points are -2 and 2. All right. Step 2, I'm going to make my sign chart. All right, so I make my sign chart, -2, 2. My derivative is right here. And let's plug in some values into my sign chart. Well, how am I going to go about doing this? Let's plug in, I'll say, some values. Hopefully you can choose them. I'm going to choose -3. Let's choose 0, then positive 3. Right. When I plug negative 3 into my derivative is right here, right? So I want to plug it into my factor derivative. When I plug it in, I'm going to get negative 3 plus 2, negative 3 minus 2, and g of negative 3. Right? And what does that equal to? Well, I need to figure out whether it's positive or negative, right? Well, negative 3 plus 2 is negative. Right? Negative 3 minus 2 is also negative. And this one's where it's sort of tricky. This is where like the problem solving part comes in. G of negative 3. How do I know whether that's positive or negative? Because I'm not given my function g, I'm given f prime of x. How do I know what g of negative 3 is equal to? Well, read the problem carefully. So think about that for a moment. And if you read the problem carefully, you'll notice g of x is less than 0. That means g of x is negative. So g of negative 3, it doesn't matter what the x value is. It is always negative. G of x is always negative. So I'm going to say this is negative. Now, 3 negatives multiplied together, that is going to be a negative. All right, hopefully that makes sense. So we're going to do another one. So if that doesn't, just follow along with me on this second one. I plug in 0, so 0 plus 2, 0 minus 2, g of 0. 0 plus 2 is a positive number. 0 minus 2 is a negative number. G of 0, again, g of anything is less than 0. That means g of anything is going to be negative. Right, so it's automatically, I just know this is negative. G of anything is negative. All right, positive times a negative, that turns out to be positive. Cool, so let me label my sign chart actually, positive and negative. All right, finally, f prime of 3, I'm going to plug it in. So that's going to be 3 plus 2 times 3 minus 2 times g of 3. That's equal to, well, it's a positive number, G of 3, remember, it doesn't matter what it is, it's a negative number. So my final answer is negative, my final interval. Cool. Negative to a positive for my derivative, that means my function would go from decreasing to increasing, right? Negative slope to positive slope. So this is a minimum. At 2, I go from positive to negative, or positive slope to negative slope, increasing or decreasing, right? So this is a maximum. My answer is B. All right, hopefully that makes sense. Okay, final one, inflection points, right? How do I find whether something's an inflection point? Well, I'm gonna do my sign chart, right? Actually, sort of jumping ahead. First, I'm gonna take my second derivative, it's set it equal to 0. So my second derivative, what is my second derivative? Well, they gave me my second derivative. So again, easy because I don't need to calculate for anything. Right, so this is set equal to 0. So let's solve for where my possible inflection points are. Actually, I'll write step 1. Step 1, possible inflection points. Solve for my possible inflection points. X times x plus 1 times x minus 2 is squared is equal to 0. So x can be equal to, let's see, it could be 0 based off this. It could be negative 1 based off this term. It could be positive 2 based off that term, right? Those are my possible inflection points. Step 2, I'm going to do my sign chart of my second derivative. So I'm going to say my second derivative sign chart. So let's write that out. Second derivative. My sign chart is negative 1, 0, 2. All right, let's figure out my sign chart. Each interval, let's plug in some numbers. First interval I'm plugging in to the left of negative 1. I'm going to try, let's say negative 2. Then my next interval, I'll try, I guess, negative 0.5, which is not the most fun to plug in, but that's all right. And then between 0 and 2, I'm going to plug in 1. Then finally, I'm going to plug in 3. All right, let's try to plug all these in. So when I plug in negative 2, I'm going to get, let's see, negative 2 times negative 2 plus 1 times negative 2 minus 2 squared. I'm gonna do these mentally, but you can always obviously use a calculator for this. So for me, that's negative, negative, positive. So this should be positive. All right. F double prime of negative 0.5. I'm gonna write this out. All right, to me, that's negative, positive, positive. So this should be negative. Finally, f double prime of 1. That's 1, 1 plus 1, 1 minus 2 squared. That's equal to positive, positive, positive. So it's positive. This one is positive. All right, final interval 3, 3 plus 1, 3 minus 2 squared is equal to, this one should also be positive. All right, so once I figure out these intervals, remember, what is the definition of an inflection point? I'm going to write this out right here. Definition of inflection point. Remember, the second derivative must change signs, aka the concavity must change. All right, so where does the second derivative actually change signs? Where does the concavity actually change? Right here, the concavity would have to change. Well, it changes at -1. It also changes at 0, but it does not change at 2, right? Here it's positive to positive. My concavity does not change. It's concave up to concave up. So my only actual answers are -1 and 0. So my answer is going to be C. All right, hopefully that makes sense for these 3 multiple choice. Everything else is just based on reading your charts, reading your graphs, and I'm hoping y'all have had time to make sense of that, especially on Delta Math if you still need to do that. If you have any other questions, please let me know, and hopefully this was helpful. All right, bye everyone.